Hi, I'm Phil. I'm a software QA analyst with Geocortex, and today we're going to be looking at using GNSS receivers with the Geocortex Mobile app. Geocortex Mobile now supports the use of GNSS receivers, which can be used to collect stunningly accurate GIS data. In today's tech tip, we're going to be looking at the use case of a city employee who's been tasked with updating some features following some construction in the city. So we begin our journey as we usually do in ArcGIS Online or in your Portal Enterprise environment. I'm going to go over to my content section and I'm going to create a new feature with which I'm going to collect some data with. Once I've selected one of my templates that I would like to use, the important next step is to click this box here for capturing GPS receiver information. This will add a number of GNSS metadata fields to your feature, including things like accuracy, number of satellites used, and the type of fix that was used to record the location. Once I've created my layers, or if I've got some existing layers, I can support this feature by simply manually adding some of those fields in. And then I'm going to take my features, put them into a web map, and then take that web map over into the Geocortex Mobile Designer. I can create a new app by simply using one of our existing templates, but in this case I've already created an app and I'm already ready to go. So I'm going to go over to the map panel on the side. We're going to see my web map that I've already configured, along with the feature layers that I would like to use. And next up, we're going to take a look at the Gns Settings Panel down here at the bottom. All GIS data is stored in some form of spatial reference system. By default, most ArcGIS Online and Portal environments store the data in Web Mercator, which is what this value here corresponds to. This is the well-known ID or WKID value corresponding to that Web Mercator. Most GNSS receivers do not necessarily project the data right off the bat, and so instead we've simply given you the GCS value for WGIS84, a very common value. As an administrator, I can configure this based on what device that I'm using, what correction services I'm utilizing in this case, and that way I can make any changes that I need, so that way my data gets correctly projected into the same spatial reference as my web map. We also give you the ability to restrict access to this for your field users. By default, we leave this turned on, so a field worker can fire up the app and make changes as they need, but if you want to be very certain that the data that's being collected is stored in a particular system, you can toggle this off to make sure that it's always going to be stored in the system that you specified. As of this release, we are currently supporting Trimble R1 and R2 devices on Windows and Android, as well as all of the EOS Aero devices on all platforms. Once I've got all of this configured, I can simply save my app, and then it's going to be ready for field usage. Once I'm ready to head out into the field, my first step is to take my preferred mobile device and Bluetooth pair it with a GNSS receiver. So we'll go into Settings, and Connections, and Bluetooth. It's going to do a local scan to find the various Bluetooth devices that are nearby, including my GNSS receiver at the top. Tapping on that simply causes them to become paired. The pairing is now complete, and I'm ready to launch Geocortex Go. Since I've already signed in, it's going to remember my credentials and take me directly to the app selector screen, which will show me a list of all the apps that I've got available to me, including the GNSS app we just created in the mobile designer. Once this is loaded, I can simply tap on it. It's going to open it up, and I'm going to see the content from my web map. Now, since I'm going to go work out in the field, I want to set myself up for working in offline mode, so I'm going to open up my map areas and activate a custom map area that I've created earlier, which contains some of the fire hydrants, sidewalks, and buildings that I'm going to work with. Now, if you notice in the bottom right-hand corner of the screen, we show you how accurate your current location is being reported. Right off the bat, we simply provide you the value from the integrated receiver of your device, and you can see some of the metadata that's provided here. To switch to my receiver, I simply go to Change Devices, pick the one I'd like to, and now I'm taken to a user settings screen which matches what we saw in Designer. So here I can provide an antenna height. If I'd like, I can change the well-known ID for the receiver that I'm using. So there's again that WGIS84 value from before, but I'm using an SBAS system, so I'm going to update that. And now I have a list of various transformations that I can make, so that way all my data ends up in the same system. Once I go back to that metadata screen, you can now see that I'm getting much more precise information with no error messages corresponding to my GNSS receiver. And again, that accuracy indicator has now updated to be much more precise and showing good lock. So I'm going to update a fire hydrant by simply clicking on it. You'll see there's all these extra metadata fields which have not been populated. By going into Edit, I can now pin this to my current location by clicking the Record Current Location button, which updates the geometry, moves it over to me. And when I click Save, we'll see that all of a sudden we've now stamped all that metadata into the appropriate fields. In addition to collecting point data, I can also collect polylines or polygons, such as updating some sidewalk information. I can manually put points on the map, or I can use that same Record Current Location button to have it pinned to my location, or as you saw there, I can use a mixture of both. Once I click Save, that feature will be there, and now both of those feature updates are ready in my map area to push those changes up to the cloud once I get back online with the Send Changes button. This concludes the functional demonstration of our current GNSS support. As I mentioned during the designer setup component, we currently provide support for Trimble R1 and R2 devices, as well as for the EOS Aero series. If there's a particular manufacturer model of GNSS receiver that you would like to see supported in a future release, please feel free to email us at info@geocortex.com. That will also be in the description below. Send us an email, let us know what sort of receivers you're using, and we'll attempt to provide support for that in a future release. Thank you very much, and have yourself a great day.